Are you tired of always monitoring your plant? Then Project Eve is the solution you need. Today we will demonstrate Project Eve, which is an autonomous self-monitoring robot whose main purpose is to monitor the plant's sensor variables and triggers a respective actuator. The three sensors we chose to use for this project is the moisture sensor, the thermistor, which measures heat, and the photoresistor, which measures light. The user sets its desired ranges for each value based on which plant they would like to monitor, as all plants require different amounts of nutrients. If these values fall outside of the desired range, an actuator will be triggered for each scenario. If the moisture sensor falls out of its desired range, a water pump will be activated, which will send water straight into the plant via a tube. If the temperature is too cold for the plant, a blue LED will be triggered, indicating the plant needs to be heated. If the temperature is too hot for the plant, a fan connected to the DC motor will be triggered. Finally, if the photoresistor detects a shortage of light, a white LED will be triggered, indicating the plant needs more sunlight or artificial light.
So here is Project Eve's VI. So here on the left, you can see we have our human-machine interface, which gives us all the charts of our variables, so light, temperature, and moisture, as well as some indicator lights, which tells us what's going on if the sensors are active and the actuators are active, basically, as well as the current temperature, percentages, and the thresholds that are being read from the cloud. Over here, we have our block diagram, which looks pretty complex, but it really isn't. It's pretty straightforward. So right down here in this big loop is the program actually reading the sensors and controlling the actuators. So basically right here we have on the left, we have our sensors being read, and then all throughout basically our variables are being manipulated into percentages and then powering some lights, which then in turn basically power, and all these digital pins over here, they power the actuators. So for example, the water pump, the fan, the LEDs, all through here. Up here we have our publishing of multiple variables. So right here we have a concatenation block, which basically connects all of these string variables into one big string, which is then sent to the cloud. As well, up here we have our subscribing 4 variables from the cloud. So basically this block here searches the RX topic value for this light threshold keyword, and then if it's there, it will set the RX value equal to light threshold, and it's the same for all 4 cases. So now we're going to demonstrate the actual execution of the project. So right now the program is running, and it's already connected to UbiDots, so I've already published and subscribed to UbiDots. So you can see here as I change this light threshold up to, say, I don't know, 33, it changes on here as well. And so for example, if the light percentage right now is around 45, so if I change the threshold over here on UbiDots to, say, 60, now it's underneath this threshold, so there's low light and that light is on, and you can see over here on our circuit the white LED is on. So again, I'll bring that back down just so that the light will turn off. And so for example, the moisture, right now the moisture percentage is around 18%. And if I raise this moisture right to about there, then the pump is going to turn on. You can see the pump is running there, and it's watering this plant, which we can see by the water coming up right over there. So now let's lower this back down just to turn off the pump, and you can see the pump goes back down. And so same thing with the temperature. For right now, the temperature is room temperature, so it's around 23 degrees. But if we change this to, say, around there, it's 25 degrees, which this is now too cold. 23 degrees is underneath our low temp threshold. So this blue light indicates that it's too cold. And then lastly, what we have to do is the high temp threshold. So if we lower this upper temp down to right about there, you can see that the fan turns on because it's too hot now. The computer thinks it's too hot, so now it's cooling down the plant with this fan attached to it right here. And as we bring this value back up, the fan will stop. Just like that.
One problem we faced in this project was the lack of current going through the circuit due to having too many sensors and actuators. To solve this problem, we used a motor driver and external power supply to power the DC motor for the fan and the water pump. Another problem we faced was publishing and subscription of more than one variable. This was solved using Mustafa's video. For the publishing of multiple variables, we use a concatenation block to combine multiple strings together. And for the subscription of multiple variables, we use a match pattern block which reads the RX topic and searches for certain variable names and then sets the values equal to the RX return value.